In this video, I'll demonstrate how to wind 6 axial generator stator coils all at the same time, and all inside the stator at the time of winding. Winding coils is tedious business, and it can be an error-prone process. In a previous video, I demonstrated how to make this axial generator. For that particular model, I wound the coils outside the stator to be inserted in a press and click type manner. This works well for a single stator model, but what if we want to add additional stators and rotors? Well, then the protruding coil sockets no longer represent the best design. So let's take a look at a more efficient and semi-automated fashion, furthermore one that eliminates some potential errors from the manual process and is vastly more fun to do. As you can hear, my voice is pretty shot after a bout of pneumonia, so please bear with me. These are our design goals. To automate the manual process, winding so and so many terms of wire is an error-prone endeavor in which a sudden lapse of focus has a tendency to render useless not only the coil itself, but more importantly, one's self-esteem. Please don't ask how I know. Eliminate the protruding coils. Adding more rotors and stators will only be worth it if we can stack them sufficiently close. Wind the coils inside the stator. In winding the coils outside of the stators, there's always a risk of not being able to harmoniously couple the coil within the stator after winding. Maximize the amount of copper wire. More wire means more electricity from the generator, and if we work inside the confines of the stator, we can then reliably cram as much copper in there as possible, since we don't have to worry about a later coil transfer. Wind all coils at the same time. Any variance in the number of turns of a coil, as introduced by an error in counting, invariably introduces ripples in the voltage, and thus inefficiencies in the output voltage. Granted, for do-it-yourself purposes, this is not a showstopper, but ideally we should seek to avoid it and aim for the exact same number of turns in each coil. And finally, most importantly, eliminate tediousness, because manually winding away at a coil is, quite frankly, in dullness only comparable to watching paint dry. That is to say, it's simply no fun at all. And if something is no fun at all, we owe it to ourselves to at least try and make it bearable. All the above notions are certainly not novel. Relatively speaking, it didn't take very long after the advent of wound stators until automatic coil winders came to be. Some of the latest fully automatic coil winder machines are truly modern marvels of engineering. As do-it-yourselfers and tinkerers, we are usually more limited in budget, so I suppose we can best aim for a semi-automatic approach in which some of the preparation steps are done by hand, but the bulk of the action will be automated. And so, without further ado, here's my design proposal. It took me a few design iterations to arrive at a functional device. In just a minute I'll get into how to build and assemble it. For now, let's do a quick tour. The winder sandwiches a stator between a base and a top. The stator is fixed tight with a number of set screws, which interact with a number of inserts which have been heat set into the base. As the stator has room for 6 coils, a corresponding number of rolls feed the copper wire into the coil sockets, past strategic holes in the stator design. The copper should ideally be kept straight to ensure a tight binding into the coil, so we position a number of holding platforms from which the copper is fed from the rolls towards the stator. The top and bottom of the platforms are topped with round Velcro stickers and can be easily taken apart. The copper wire travels through the natural gaps in the Velcro and thus remains helpfully fixed in place. A central gear interacts with smaller coil winder gears. These smaller gears are positioned on top of a 3D printed coil core from which 2 prongs extend to grip the gear. As I'll later demonstrate, the copper wire extends through the core and coils up when the gears interact. These are the parts we need. 1 base plate, 1 coil winder base, 1 coil winder top, 1 center gear, 6 coil gears, 6 coil rollers and 6 coil roller holders, 6 wire holding platforms with 6 corresponding top pieces. Those are the 3D printed parts, but we need a few off-the-shelf bits and pieces too. The selection presented here is not definitive, rather what I had lying around. You can easily adapt the Tinkercad-design to suit other types and sizes of parts you may wish to use instead. We need one M8 bolt or socket screw or similar 8mm rod to fix the center gear in position. I've grown personally very fond of these socket screws that I get when I take apart discarded roller blades. For the purpose of providing support for the coil cores and smaller gears, we need 6 M3 bolts 40mm or greater length. These will go into the coil winder base and provide support for the coil cores and smaller gears. And we also need 6 washers and 12 nuts for fixing the gears in place. For the purpose of fixing the stator to the winder top and base, we need 12 threaded insert nuts, M3 x 5 x 4mm. These will be burned into the winder base and provide support for screws that tighten the stator and winder top part down. I'll soon demonstrate how to insert them. You don't have to use these if you don't have them, nor care to order for them. You can use regular threaded screws instead that drill into the base. These will work for a few iterations, but then you'll likely have to repair or replace the base. The inserts allow for greater reusability. Correspondingly, we'll need 7 M3 hex socket screws 12mm, 5 M3 hex socket screws 8mm. For the purpose of winding and holding the copper wire, we need 6 bolts or socket screws for the coil roller. They should fit tight over the rollers but loose over the coil roller holder. Again, you should absolutely adapt the Tinkercad design to any bolts or rods you may have lying around. Velcro pads, preferably 20mm diameter. You could also cut pieces from Velcro bands, more typically available. Finally, we need a bunch of small screws to fix the components to the base plate. And that's it for the coil winder itself. When comes the time to put it to actual use, we'll need additional expendable parts, namely one stator with features such as wire canals and conduits for adhesives, 6 stator cores, a few pieces of paper, ideally though not necessarily shaped like the stator itself, some super glue to fix the coils in place after winding, a bit of tape will come in handy at times, and of course the copper wire. The coil winder is designed in Tinkercad and it's available for free in the description. Don't fret it if Tinkercad is something you haven't tried before. You don't have to know how to use it to print the design. Simply click on one of the elements and press the export button in the top right corner. Then proceed to select the STL format that your 3D printer software, or slicer as it's known, will know how to process into something your printer will be able to print. If only for reference, I print with a 0.8mm nozzle, which allows me to rapidly lay down a lot of filament. If I combine this nozzle side with a layer height of 0.5mm, I can print a stator in 47 minutes. I could likely print at a faster speed on my Creality Ender 2, no affiliation, and get this down to 30 minutes. It's a great printer, it's that simple to use, and I'll recommend it to anyone. It has a particular feature that's great for this particular project. The top of the base of the coil winder should ideally be as flat as possible, for purposes of which will later become apparent. I placed a note on this object in the design to indicate how this object is best printed, with its top facing side being faced away from the printhead. The Ender 2 Pro has a magnetic adhesive surface cover, and so when the print is done, we don't have to scrape the print off. We can simply extract the entire cover and slowly peel off the print with little risk of degrading the smooth surface. It has to be said that it's only for the larger parts that I print with a 0.5mm layer height. The coil, cores, gears and rollers are printed with a layer height of 0.2mm. As for these smaller parts, we need more layer detail. The inserts must be merged into the base. It's a relatively straightforward affair. Suspend the inserts by pinchers or suitable pliers and apply heat with a soldering iron or similar before pushing the insert into the print. Ideally, it should be flush with the print, but it can be tricky to judge. When in doubt, aim to push the insert about a half or whole millimeter below the print surface. If any plastic residue breaches the print surface, you can sandpaper it away. Now for the assembly. First order of play is to drill a hole in the base plate big enough to fit your center gear bolt or rod through. The bolt should be able to rotate freely. I'm attaching an 8mm socket screw to the center gear, so I drill an 8mm hole and wriggle the drill around a bit to make the hole just a little bit wider. I also drill holes in the base plate in case I wish to later fix it into the table so it won't slide around when time comes to use the winder. Position the center socket screw or bolt. The base of the coil winder goes over the socket screw. Two countersinks allow for the fixation of the base into the base plate. For now, we'll add temporary screws, as we'll later retrieve the base and add some bolts to it. Then we can add the coil rollers and wire holding platforms. These should be strategically placed in close proximity to the winder, yet aligned in such a way that each coil roller can be individually accessed when the time comes to load them. It's worth considering the updated stator design here, where you'll see 3 openings, 3 canals on either side of the stator, offering a pathway for the copper wire. Ideally, the platforms should be positioned in reference with the placement of those openings. The platforms have countersinks to them, so fix it with a screw to the base plate and firmly press a Velcro pad onto it. The top pieces should accordingly have the matching Velcro pad pressed into it. Fix the coil roller into place and add a roller. Here I again use my favorite socket screws. You may be using a bolt instead. Never matter the choice of material, the roller should be able to rotate freely. Repeat 5 more times and you should end up with a setup similar to this. Now let's add the 6 coil bolts. Unfasten the base and flip it over. You'll find 6 countersinks for the 6 coil bolts. It's a reasonably tight fit, so I suggest you start by simply turning the bolts once or twice in the designated spot. Then it's just a matter of letting a drill bit do the talking. Place the base back down on the base plate and fasten it tight. Now for the fun part, using it to produce a fully coiled stator. The use of the winder is a multi-step process, none of which are particularly complex, which is not to say that practice won't make perfect. With the stator in place, we can start to contemplate loading the coil holders. As we're aiming for simultaneous coil winds, we'll have to prepare 6 individual rolls for the 6 coils. It's actually a rather fun process. Fix one end of your copper feeder roll to the roller with a bit of tape and then, depending on your choice of attachment, wind the copper onto the roll. I suggest you keep the copper wire tightly suspended to avoid potential wire crossovers. I recommend using 0.2mm copper wire or greater width. 0.1mm is simply too brittle and prone to break. Try to guide the wire to oscillate back and forth across the roller to even out the flow. It won't take you long to fill it up, beyond which we can lock it down by placing the wire on the platform and putting a lid on it, so to speak. Snip off the wire and repeat for the 5 remaining rollers. Then it's mounting the stator. Preferably the base of the winder has been printed face down, so the surface of the top face is smooth. Let's add a piece of paper, which will later on prevent superglue from exiting into the base. The stator has countersink holes for 5 screws. Use these to fix the stator tight to the winder base. Next up, rigging the cores. Guide one of the wire rolls into its corresponding opening in the stator, and you should, of course, naturally target the closest opening of the 3 available on the stator side. A pair of pliers will come in handy here, as it can be difficult to retrieve a thin wire from the coil socket. Now take a coil core and needle the wire through the single hole in the side. Extend 3 or 4 inches of wire and slide the core down over the fixed coil bolt. There should be the narrowest of spaces to allow for that. Repeat for the 5 other coil cores. Let's go ahead and close the lid. It's perforated by a number of holes, big and small. You can check the correct alignment by regarding the placement of the unoccupied screw holes. The medium-sized holes, 6 in total, are where the exposed strands of wire go through. It's a tight fit, so expect to have to wriggle the lid around just a bit to accommodate for the 2 prongs extending from each coil core. Eventually you'll be able to close it and fix it with 7 bolts. The lid should be closed tight, but the cores should still be able to rotate freely in their sockets. Setting up the gears comes next. First, the individual coil gears. You'll notice how the inside pattern fits over the coil bolt as well as over the 2 prongs of the coil core. Insert the wire through the gear. Slowly mesh the gear into place whilst keeping the wire to one side. On one side of the gear you'll notice a tiny slot gap. Wind the exposed wire through it and around the gear until you can fix it in place with a bit of tape. Now just repeat with the other 5. Mesh the center gear into place. Fix the coil gears in place with 1 washer and 2 bolts for each gear. Don't tighten them too tight, they should be able to rotate. And so we're ready to wind our stator. I recommend doing the first few turns by hand as opposed to immediately donning a power drill and letting it rip. A ratchet driver works great for this purpose. When we're done turning a few slow turns and nothing seems to resist the turn, we can change the tool to something a bit faster. I drew the turn direction onto the base plate so as to not forget. It's easy to be distracted and wind the wrong way. Once again, don't ask. I find it fascinating to watch all the coils wind at the same time. The larger holes in the lid allow us to follow the process, at least when the coil has wound beyond the diameter of the gear. Because of this feature, it becomes effortless to wind to the very edge of the coil socket. The gears should turn in unison and thus ensure the same number of turns for every single coil. It's important to be gentle with the power drill. The prongs are fragile and rotating the drill too fast will accumulate stresses into them. As you approach the outer edge, I recommend slowing down and even reverting to the ratchet driver for a few final turns. We can't just pop the lid yet. We still need to apply some glue to prevent the coils from jumping out of their sockets. That's what the larger holes in the lid are also for, to easily access the conduits into which the glue can be poured. Careful to not go overboard here. We don't want to glue all the layers together. Allow for the glue to cure for a bit. Now we can disassemble the winder and release the wound stator. Having come this far, there's every reason to be mindful of this process and take the required time to do it slowly and methodically. Be particularly careful as you gently jerk the lid off. By all means, use any available tools for added assistance. With the lid having come off, find further opportunities to apply a bit of superglue, so don't hesitate in that. Snip off the 2 prongs of each expendable coil core. I suggest covering the stator in tape to protect the coil surfaces. And there's the finished stator. And there you have it, semi-automatic multi-coil winding. If not on par with multi-million-dollar machines, you'll at least somewhat cheaper and fully reusable. In a very near future, I'll make good use of this and construct a generator with multiple rotors and stators So consider subscribing so you won't miss out on that. Thank you for your time.